So the next problem, show that of all the rectangles with a given perimeter, the one with the greatest area is a square. Now I am going to prove that. So the rectangles with a given perimeter, the one with the greatest area is a square. So if you are taking a rectangle, if the rectangle has got a maximum area with one of its perimeter, then we are going to prove that it is a square. So this is the meaning of the question. First thing I am taking, let x, y be the length and breadth of a given rectangle, So then the perimeter, I am taking perimeter as L. Suppose I am taking L is a perimeter, then perimeter L is equals to 2x plus 2y. 2x plus 2y. Because the perimeter, we know that suppose x and y are the length and breadth of the rectangle, then I can say the perimeter of the rectangle is 2x plus 2y. Therefore, I am taking L as a perimeter. Your L is equals to 2x plus 2y. From this I can say your 2y is equals to L minus 2x, or your y is equals to L minus 2x divided by 2. Now A be the area, let A be the area, then I can say your area is equals to length into breadth, x into y. So your area is equals to x into y is nothing but L minus 2x divided by 2. Now you multiplying, A is equals to Lx minus 2x square divided by 2, where L is said to be a constant because L is a perimeter, given perimeter, therefore I am saying L is constant. Now you find out, to find whether it is a maximum or minimum area, I am going to find out the first derivative and the second derivative. Therefore I can say your dA by dx is equals to what? Lx differentiation L minus 2x differentiation will get 4x divided by 2. So then again you are differentiate d square A by dx square, we are getting the second derivative which is equals to L becomes 0, minus 4x becomes minus 4 divided by 2, which is equals to minus 2. Now to find the value of x value, therefore I can say your dA by dx equals to 0. dA by dx equal to 0, which implies L minus 4x by 2 is equals to 0. Or from this I can say your L is equals to 4x. To find out whether it's a maximum area or a minimum area, therefore I can say put L is equals to 4x in d square y by dx square becomes minus 2. Because minus 2 here it is constant, therefore less than 0. Since it is a less than 0, I can say the area is maximum. Therefore the area is maximum. The area is maximum. So the first proof we have proved, the area is maximum. If it is area is maximum, I am going to prove that the area of a rectangle is a square. It is equals to square. Therefore, the rectangle becomes square. I have to show. What is the meaning of square? The length and breadth are same. I am going to prove that x and y are equal. Therefore, you consider, substitute, we know L is equals to 4x. Substitute L is equals to 4x in the first one. That is, L is equals to 2x plus 2y. Then L is equals to 4x. If you get 4x is equals to 2x plus 2y, or 2x becomes 4x minus 2x equals to 2x equals to 2y, or x equals to y. As I told you, if x is equals to y, then length and breadth are same. If length and breadth are same, then it is should to be equal to square. Therefore, we can say the greatest area, therefore the rectangle with a, therefore I can say the rectangle with a given perimeter L, with a given perimeter with the greatest area is a square. So simply we have proved. So it is given that it is a rectangle. See, again you will read the question here. Show that of all the rectangles with a given perimeter, the one with the greatest area is a square. I have showed that it has the rectangle has a maximum area, it's the greatest area, and also I have proved that your length and breadth are same, which means it is a square. So this is this problem, okay? So it's a very simple and easy. It's one of the problem from maxima and minima. So always remember the working steps, working rules of maxima and minima, and then go for this problems, okay? It's a very easy one. Don't think that it's a tough one. It's all very easy in maxima minima. Once you are clearly understand the problem, understand the question, then you can able to solve the problem very simply, okay? Next we'll pass on to the next problem. It's very simple. And also it's a very easiest problem. Okay. So don't forget that it's a very easiest problem. So under the section called Maclaurin series. Under the section called Maclaurin series. So let us take down. Expand log 1 plus x using Maclaurin series. You all know what you mean by Maclaurin series. You know the formula for Maclaurin series. Therefore, let us take your Maclaurin series. So it's just we need only the skills, knowing the formula. That's all. Applying the values, we'll get the answer. So what is the formula of Maclaurin series? I have given in the beginning of starting this differential calculus. I have given the Maclaurin series formula. That is your f of x is equals to f of 0 plus x by 1 factorial, f dash of 0 plus x square divided by 2 factorial, f double dash of 0, and so on. So while solving this type of problems, you have to be very patient. So you may find out some small error, small mistakes, silly mistakes you can find out. But therefore you have to be very patient and solve the problem very carefully and with patience. Okay. Therefore first one, let us take f of x is equals to given. It is given in your problem, your f of x is equals to log 1 plus x. If you are taking f of x equal to log 1 plus x, immediately you find out what is f of 0. If you put log x instead of x, if you put 0, log 1 becomes 0. The next one, find out f dash of x. Up to 5 derivatives you have to find out. Therefore, f dash of x, which is equals to 1 by 1 plus x. Therefore, your f dash of 0 is equals to, if you substitute x equal to 0, 1 divided by 1 plus 0, which is equals to 1. Next one, f double dash of x. So differentiation of 1 by x is what? Minus 1 by x square. Similarly, I can say minus 1 divided by 1 plus x the whole square. Otherwise, you can write this as minus of 1 plus x the whole power minus 2. F double dash of 0. If you put x is equals to 0, we will get minus 1. Therefore, the answer is minus 1. The third derivative, f triple dash of x is equals to differentiation of minus 1 plus x equals to minus 2. X power n differentiation, n into x power n minus 1. Similarly, minus into minus plus 2 into 1 plus x whole power minus 2 minus 1, which is equals to minus 3. Therefore, I can say f triple dash of 0 is equals to x, substituting x equal to 0, 1 plus 0 plus 1, 1 power anything is 1, 1 into 2, which is equals to 2. Next one, f4 of x. Again we are differentiating, minus 3 2s are minus 6, 1 plus x, minus 3 minus 1, which is equals to minus 4. f4 of 0 is equals to, substituting x equal to 0, I'll get minus 6 into 1, which is equals to minus 6. At last you find out f5 of x is equals to 24 into 1 plus x whole power minus 5. If you put x equal to 0, 1 into 24, we'll get 24. Now you substitute all the values of f of 0, f dash of 0, f double dash of 0, and so on in the Maclaurin series. Therefore, I will get f of x is nothing but log 1 plus x. Your log 1 plus x is equals to f of 0. What is f of 0? 0 plus x by 1 factorial. F dash of 0, what is f dash of 0? 1 plus x square by 2 factorial. F double dash of 0, what is f double dash of 0 is equals to minus 1. X cube by 3 factorial, f triple dash of 0 is equals to 2, and x power 4 by 4 factorial into minus 6, and x power 5 by 5 factorial into 24, and so on. Now I can say x by 1 factorial is 1 into 1, x square by 2 factorial is 2 into minus 1, then x cube by 3 factorial into 2, 3 factorial is 6 into 2, plus x power 4 by 4 factorial is 24 into minus 6, plus x power 5 by 120 into 24, and so on. So therefore you can say 2 it will go 3 times, 6 it will go 4 times, 24 it will go 5 times. Therefore I can rewrite this as x plus minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus x power 5 by 5, alternate symbol plus minus, and so on. This is the answer. Okay. So if you get this question in a public examination, you are a very luckiest person. So therefore it's one of the very simple, just if you are knowing the formula, you can easily solve the remaining problems. Okay, always remember that the Maclaurin series f of x is equals to f of 0 plus x by 1 factorial f dash of 0 and so on. Substituting the values of f dash of 0, f double dash of 0 and so on into the remaining series, then you will get the Maclaurin series. So it's a very simple and easiest problem. So if the problem comes, don't leave this problem. Okay.